Welcome back to science class. My name is Ms. Rillieux, and this week we will be discussing conductors and insulators. Again, this is the same teak that we discussed last week, but there are multiple components of the teak. So this is our second part to our series for this standard. Now, if you joined us last week, we discussed the three phases of matter: solid, liquid, and gas. So before we can begin with what is a conductor and what is an insulator, let's review what we did last week. So to review what we did last week, we're going to play Jeopardy. So grab your notes, grab your foldable, and let's begin. So states of matter for 100. Tightly packed and vibrates in place. Yes, you should have said it is a solid. States of matter 200. Particles can slide past each other. Right again. You should have said, what is a liquid? States of matter for 300. Particles take the shape of the container that it is in. Excellent. You should have said again, what is a liquid? States of matter for 400. Fastest moving particles of all of the states of matter. Right again. What is a gas? And then states of matter for 500. When you add energy to liquid, what happens to the particles? Correct. When you add energy, the particles are going to move faster. So before we continue with our Jeopardy game, let's review what we just learned with those 5 questions. First, we learned that a solid has the particles densely packed, and the solid particles, they just vibrate. On the other hand, liquid particles have more energy. Thus, they move more. Liquid takes the shape of the container. And then last but not least, we learned that the particles that move the fastest are those of a gas. Now, let's go to the next category. It is named changing states of matter. So for 100, the question is a change of state from a solid to a liquid. What do we call that? Yes, when we change from a solid to a liquid, we call that melting. Think about ice. Ice is a solid, water is a liquid. And so if we want to go from ice to water, we must melt the ice. States of matter for 300. The change of liquid to a gas using heat, no boiling. Perfect. It is, what is evaporation? Think about when you're in a shower. States of matter for 200. Boiling water becomes a. So what happens when we boil the water? It becomes a, great job. It becomes a gas. Changing states of matter for 400. A change from a gas to a liquid. Correct. When we change from a gas to a liquid, it is called condensation. Changing states of matter for 500. Last question. Changing from a solid directly to a gas. Right. When we change from a solid directly to a gas, we call that sublimation. Moving on to our third column, it is labeled, it is a solid, a liquid, or a gas. So we're going to identify which of the 3 it may be, starting with number 1 for 100. Milk. What is milk? A solid, a liquid, or a gas? Yes, that milk that they serve in the cafeteria every day is a liquid. Is it a solid, liquid, or gas for 200? What about an apple? Correct again. An apple is a solid. Is it a solid, liquid, or gas for 300? Helium in a balloon. Excellent job. Helium in a balloon is a gas. Solid, liquid, or gas for 400. Carbon dioxide, what we breathe out every day. Is it a solid, liquid, or gas? Yes, carbon dioxide is a gas. And last question for 500, is it a solid, liquid, or gas? Frozen carbon dioxide. Right. If you guess that frozen carbon dioxide is a solid, then you are correct. The key word here is frozen. Let's go to vocabulary terms. There are 5 questions within this category. Let's start with number 1. So the first question says, vocabulary for 100, anything that has volume and it takes up space. Right. The answer to this question would be matter. So basically everything around you, your computer, your phone, your paper, they all are matter because they have volume and they take up space. Vocabulary for 200. Solid, liquid, and gas are the 3 types of. Yes, a solid, a liquid, and a gas. They all represent the states of matter. Vocabulary for 300. A physical change when matter changes from one state to another. Perfect. We would call this the change in states. Vocabulary for 400. The measure of how hot or cold something is. Correct. If we're measuring how hot or cold something is, we call that temperature. And last question for 500. How much space a substance takes up? Yes, the amount of space a substance takes up is called volume. So last column, there are 4 questions, true or false, going through everything that we have reviewed so far on the 3 states of matter, solid, liquid, and gas. So starting with true or false for 100. If you want to find out the mass of something, would you use a balance? Yes, that would be true. If you want to find the mass of something, you would use a balance. Sometimes in class, you see something called a triple beam balance. True or false for 200. You could use a ruler to find out the length of a car. That would be false. You could use it to find the length, but it would take a very long time, so it wouldn't be the best option. You would have to do it like over and over. So for 300, the freezing point of water is 212 degrees Fahrenheit. That is true. And last question for 500. If you take away energy from matter, it makes the particles go faster. Right. That would be false. When we add energy to matter, it makes them go faster. It does not make them go, when we add energy, it makes them go faster. When we take away energy, it makes them go slower. So again, to review what we did last week, we talked about the 3 phases of matter: solid, liquid, and gas. A solid has the particles densely packed together and the particles simply just vibrate. On the other hand, a liquid particles are faster, and those particles, they are not as densely packed together. They are more spread out. And then last but not least, gas represents the fastest particles, and that's why they do not have any volume. All right, so now that we have reviewed what we did last week, let's get into this week's lesson. So for this week, again, this is a series. The standard that we will be reviewing in this series is students will be able to classify matter based on physical properties, including mass, magnetism, physical state, which we did last week, solid, liquid, and gas, relative density, sinking or floating, solubility in water, and the ability to conduct or insulate thermal energy or electrical energy. So our focus for this week is the ability to conduct or insulate thermal energy or electrical energy. The essential question that I have for you this week is the same as last week, which is, how can I classify matter based on its physical properties? Again, last week we discussed physical state, solid, liquid, gas. This week we're discussing conduction and insulation. So the agenda for today, the first thing we're going to do is complete our insulator and conductible foldable, guided practice, conductor or insulator, independent practice, quiz is, And then last but not least, the STAR test is coming up, or it is not leaving anytime soon since you have until June to complete it online. Therefore, we will be preparing for it until our time is over with this series. So to ensure that you are able to master the STAR whenever you do take it. So the materials you will need for this session include just paper, pencil, and scissors. And so now that you have your three supplies, paper, pencil, and scissors, let's create our foldable. So to create our foldable, we are going to take a sheet of paper and we are going to fold it hamburger style. So that's going to give us a little bit of length so that we can write some accurate notes about conductors and insulators. Now, once we have that folder, that paper folded hamburger style, we are then going to draw a line in the middle of one side of the paper as seen on the screen. So this side of the paper you are not going to use, but on this side of the paper, we're going to draw a line. Once you have that line drawn, you want to label that top square conductor and then that bottom square insulator. After you have your two labels, conductor and insulator, you want to take your scissors and cut them in half, cut the two boxes in half so that you will be left with two tabs, and then your foldable is created. So I'll give you about 10 seconds to create your foldable. While you're creating your foldable, if you're just joining us, welcome. Again, we're taking our paper, folding it in half, hamburger style. We are then taking one half of our paper, drawing a line in the middle, just as seen on the screen. We're labeling the top half conductor, the bottom half insulator, and then taking our scissors and cutting that line so that we can be left with two tabs. All right, so now that we have our foldable created, we're ready to learn about conductors and insulators. So let's first talk about a conductor. So a conductor is a material through which electrical charges can easily flow. So I'll give you about 10 seconds to write that down. Again, on the picture, there are examples of conductors. So brass, aluminum, cast iron, copper, steel, metal, and bronze. Those are all examples of materials through which electrical charges can easily flow. Now, conductors, many of the wires in your homes are made of aluminum. They do not conduct electricity. Of all metals, silver is the best conductor, but it costs more than copper or aluminum. And so that makes sense. If it's going to cost more, then we're most likely not going to use it widespread. We're going to find the most effective thing that most people can afford in order to use it. Again, silver is the best, but it is not the most cost effective. Now, conductors are made up of atoms that hold their electrons loosely. So that way, electrons can move freely. Our electrons can move easily from atom to atom. So what makes a conductor able to conduct electricity is due to the way that they hold their electrons. So because their electrons are held loosely, those electrons can move from one atom to the next, which allows the conduction of electricity. So it's all about the electrons. Now, some additional examples of conductors you want to add to your foldable: copper, iron, gold, water, aluminum, steel, and silver. I'll give you a few seconds to add these examples to your foldable. So now that we've learned about conductors, let's talk about insulators. So an insulator is a material through which an electrical charge cannot flow easily. Again, remember, a conductor means it can, but an insulator means it cannot. So I want you to open up the foldable in your tab labeled insulators and write down what is an insulator. As you can see, we have two examples on your screen of insulators, but to know what an insulator is, all that means is that it is a material which an electrical charge cannot easily flow. Now, insulators, right? So copper wires are usually coated with plastic or rubber. And this coating is an insulator. making it safe to touch. So if we go back to this diagram, remember, copper is a conductor, but to ensure safety, copper is most often surrounded by an insulator. As you can see on the screen here, these are insulators. The red and green is an insulator, and the gold or bronze color is copper. So copper is being covered by an insulator for safety reasons. And so the insulator is typically plastic or rubber. So most electrical power lines do not have insulation around them. So workers have to use installation tools. If you see a fallen power line, tell an adult, do not touch it. And the reason is because unlike the wires typically in your home that do have insulators that surround them, power lines do not. They're typically live and they will electrocute you. So you do not want to touch them because they can conduct electricity. And so we don't want to touch them. Now, insulators have atoms that hold electrons tightly. Remember, we previously discovered that conductors have electrons that are freely moving, and that is why we're able to conduct electricity with those materials. But on the other hand, insulators are going to hold the electrons. Therefore, the electrons will not be able to move freely like they would with a material that is a conductor. So a charge barely moves through an insulator. Now, examples of insulators include most plastics, glass, cloth, sand, rubber, wood, and dry air. All of those are insulators. So what we want to take from this diagram, and I'll give you a few seconds to fill in your notes, examples of insulators, is we want to know that a conductor is able to conduct electricity. And the reason why is because its electrons are freely moving or are able to freely move from one atom to the next. Examples of conductors would be silver and copper. On the other hand, an insulator does not conduct electricity. And the reason for that is because its electrons are not able to freely move. And so because its electrons are not able to freely move, then it is not able to conduct electricity. Now, what we want to remember, some safety things, is that in our homes, we do have material that conducts electricity, but typically those materials are covered by an insulator for safety. Yet, if we go outside and we see a power line, those power lines do not have that same covering of insulation that the wires do in our home. Therefore, if we see a live or a fallen power line, we do not want to touch it because it will hurt us. So examples of a good conductor and a bad conductor of heat. So wood handle is an insulator. So in a wood handle, the atoms, they are not moving freely. Thus, you are not able to conduct electricity with wood. On the other hand, the metal bottom or the metal part of a pot is a good conductor. Therefore, those atoms are moving freely, which means that they can move those electrons. Those electrons are moving freely from one atom to the next. All right. So now that we know the difference between a conductor or an insulator, I'll show you a picture and I want you to tell me which one is it. Are you ready? I'll give you a few seconds to review your notes and kind of understand the difference between conductor and insulator, and then we'll get started. All right. So first picture, is this an example of a conductor or insulator? And not only do I want you to tell me, is it an example of a conductor or insulator, I also want you to tell me why. So if you said that this is an insulator, you are correct. It is an insulator. The atoms in a glass, the electrons in a glass, they are not able to move freely. Thus, electricity will not be conducted, or it will not conduct heat as easily. And what about this one? Is this a conductor or is this an insulator? Yes, this is an insulator. Similar to a glass, the electrons within this mitten, they do not move freely. So because they do not move freely or are not able to move freely from one atom to the next, it will not be able to easily conduct heat or electricity. And now what about this? Is this a conductor or is this an insulator? Yes, if you answered that this is a conductor, you are correct. Unlike the previous two pictures, this material is able, or this material's electrons are able to move freely from one atom to the next. So our next one, conductor or insulator? Yes, this is an insulator. Salt is an insulator. So the glass is also an insulator. This next picture, is it a conductor or an insulator? If you answered insulator, you are correct again. The electrons in wood, they do not easily move from one atom to the next. And what about this nail? Is it a conductor or an insulator? Yes, it is a conductor. And what about a plastic spoon? Remember, there are different types of spoons, but this one is a plastic spoon. So would this plastic spoon be a conductor or would this plastic spoon be an insulator? Yes, the plastic spoon would be an insulator. The electrons within plastic, they do not freely move. Now, if I had showed you a picture of a silver spoon, a metal spoon, that would most likely be a conductor because although they are both spoons, they are made up out of different materials. So whenever we're deciding if something is going to be identified as a conductor or identified as an insulator, what we want to remember is what is it made up of? What material is it made up of? And that will give us insight into if we should label it as a conductor or an insulator. So don't want to just look at the object because there are plastic spoons and there are metal spoons. A plastic spoon is an insulator, but a metal spoon is a conductor. And here is that example. So we know that this is going to be it is going to be a conductor. Again, they're both spoons, but when we're ever deciding if something is a conductor or if something is an insulator, we do not look at just strictly the object itself. We have to look at what it is made up of. And then this last picture, this is a picture of a rubber flooring or a rubber material. So would this be an example of a conductor or would this be an example of an insulator? Yes, this would be an example of an insulator. And what about this cotton hat? Would it be a conductor or an insulator? Yes, this hat would be an insulator. All right. So now that we have reviewed different materials that represent conductors and insulators, we're going to play a little bit of quiz is before we go into our star practice question for today. All right. So is tape a conductor or is it an insulator? Right. It is an insulator. A metal spoon that gets warm when it is used to stir hot soup is an example of. If you said conduction, it is correct. What is not an example of an insulator in the kitchen? Yes, so an example of not an insulator in the kitchen would be an object that is typically metal. The object that is typically metal out of the four are pots and pans. Is a couch a conductor or is it an insulator? Right. The material that a couch is made out of is typically of some cotton material. So it is an insulator. Which is not an insulator. So that means we're looking for the conductor. So out of these four, which one represents the conductor? Yes, the conductor out of these four would be copper. A great conductor of energy is, so again, we're looking for another conductor out of these four. Which one would be a conductor? Correct. A conductor would be the metal. Is plastic a conductor or is it an insulator? Yes, plastic is an insulator. Which one is an insulator? Yes, the one that is an insulator is any ideas? Right, we can say that the mechanical pencil So which one is an insulator? This answer would be, any ideas? Correct. The one that is an insulator would be plastic. Is rock a conductor or is rock an insulator? Exactly. If we're speaking of rocks that we see outside, those are all going to be insulators. Is iron a conductor or is iron an insulator? Absolutely. Iron is a conductor. Is wood a conductor or is wood an insulator? Yes, wood is a insulator. The next question says, mittens help keep your hands warm in the winter because they are? Yes, a mitten, as we have said today, a mitten is an insulator. What's the difference between a conductor and an insulator? Right, what we learned today is conductors, they allow electricity and heat pass by because their electrons move freely, whereas insulators do not allow their electrons to move freely. Therefore, they do not allow electricity or heat to move. So the answer to this question is the last one. A conductor allows electricity to flow through it easily. Insulator does not. All right. So now let's get to our star practice question. And so the question I have for you today, a student is asked to design a sleeve for a cup that will insulate thermal energy and not feel hot to touch when the cup is filled with hot water. The student has four materials to choose from. Which of these is the least useful as an insulator? So out of the four, which one is the least useful? So if we're asking for the least useful as an insulator, what should we be looking for? Should we be looking for an insulator as an answer choice, or should we be looking for a conductor as an answer choice? Right. To answer this question correctly, we should be looking for a conductor to be our answer choice. So if we look at the four answer choices, cardboard, aluminum, rubber, and plastic, out of those four, which of those represents a conductor? Yes, that answer would be G. Aluminum is a metal, therefore it is going to be the conductor out of the four answer choices. That is everything that I have for you today. Thank you for joining me, and I'll see you next week. Bye-bye.